Mat Armstrong has returned to Miami, and this weekend marks a critical moment in one of the most ambitious automotive projects ever attempted. After successfully taking apart a Bugatti Chiron, a car renowned for its extreme engineering complexity and rarity, Mat now faces the enormous challenge of putting it back together. The stakes are high because the Chiron has been split in half and sitting at CV Customs, waiting for the painstaking process of reassembly to begin. Unlike the disassembly process, which many people assume was straightforward, the reassembly demands an entirely different level of skill. Every component must be reconnected in the exact correct sequence, and any mistake could lead to catastrophic failure. Complicating matters, Bugatti has refused to provide support for this project, leaving Mat to rely entirely on his own knowledge, preparation, and ingenuity. The doubters are watching closely, ready to claim that while taking a car apart may be easy, putting it back together without factory documentation is impossible. This project is not just about restoring a car. It is about proving that independent builders can overcome the barriers imposed by manufacturers, and that ownership should include the right to repair and rebuild vehicles purchased by customers. The weekend in Miami is shaping up to be a test of skill, patience, and engineering knowledge, and has drawn attention not just from automotive enthusiasts, but from the broader community of car owners and builders who follow the right to repair movement. The results of this rebuild will carry weight beyond a single vehicle, potentially setting a precedent that could change how independent garages approach hypercar repairs. Mat's approach is methodical. Every step of the disassembly was carefully documented, including the labeling of wiring looms, the photographing of connectors, and the cataloging of the sequence in which components were removed. This documentation now becomes a roadmap for reassembly, guiding Mat to reverse the process accurately. What was once the doubter's argument, that anyone could take apart a car but reassembly is beyond reach, will be tested in a very real, tangible way over the course of this weekend. The anticipation is palpable, as viewers and enthusiasts alike are eager to see whether Mat's preparation, experience, and ingenuity will allow him to achieve what some of the most experienced manufacturers claim is impossible. From the moment the Chiron arrived in Miami to the first bolt being tightened, every action will be under scrutiny. This project represents a fusion of extreme technical challenge, creative problem-solving, and a test of independent automotive skill, making it one of the most closely watched rebuild projects in recent automotive history. Reassembling a Bugatti Chiron is far more complicated than simply taking it apart. When a car is disassembled, the process is largely about removing components in reverse order, beginning with outer panels, and moving inward towards structural and mechanical systems. While this requires care and attention, mistakes are generally easier to spot. If something resists removal, it usually indicates an error. Reassembly, however, is a more intricate and demanding task. Every component must be installed in a precise sequence to avoid physical interference, misalignment, or damage. Wiring harnesses must be routed exactly as they were originally, because even a single misconnected plug can result in fault codes or permanent damage to control modules. Coolant lines, electrical connectors, and structural components all have specific positions that must be adhered to, and deviations can cause leaks, system malfunctions, or even compromise vehicle safety. Torque specifications are critical. Bolts cannot be over-tightened, or they risk stripping threads or cracking aluminum parts, but they cannot be under-tightened either, as components could vibrate loose during operation. Some components, such as the 14 titanium bolts connecting the rear subframe to the front monocoque, require installation in a precise order with exact torque applied at each step. Failure to follow the correct process could lead to catastrophic mechanical problems. Mat Armstrong's preparation is key to mitigating these risks. Because Bugatti refused to provide official documentation or parts for this rebuild, he has had to independently develop solutions. This includes reverse engineering certain components, commissioning CNC machine replacement brackets, and verifying each step through meticulous engineering analysis. The gearbox mounting bracket, for example, is the very component that caused the initial crash and division of the car. Mat now faces a decision of whether to use a newly machined bracket, a repaired version of the original, or a sourced used component. Each option carries its own benefits and risks, affecting the overall safety, reliability, and timeline of the rebuild. This decision demonstrates that the rebuild is not simply mechanical work, but an engineering challenge requiring evaluation, testing, and precision. The stakes are amplified by the scrutiny of doubters and enthusiasts who are watching every update, analyzing each decision and predicting potential failure. The success or failure of this rebuild is therefore about more than just reassembling a car. It is a demonstration of whether an independent builder, without factory support, can achieve results that rival or surpass those of the original manufacturer. The weekend in Miami has become a stage for this high-stakes experiment, combining technical skill, careful planning, and innovative problem-solving into a real-world test of automotive expertise. One of the most fascinating aspects of this rebuild is the level of engineering decisions required to bring the Chiron back to life. Since Bugatti refused to sell essential parts, Mat has had to engineer solutions from scratch or improve on the original designs. CNC machining plays a key role in producing replacement brackets that not only replicate, but in some cases improve upon, the original components. Every part must be tested to ensure it fits perfectly with existing systems, such as a W16 engine, gearbox, and suspension subframes. The engineering challenges extend beyond mechanical components. Airflow, exhaust routing, and electronic systems all require careful consideration. For example, the custom exhaust is being developed with precise flow dynamics in mind, using 3D printed templates and validated design junctions. Even small errors in measurement could impact performance or cause long-term damage. Mat's approach is methodical. Every step of the disassembly was documented, from labeling wiring looms to photographing each connection. This documentation acts as a reassembly guide, ensuring that each part is returned to its proper location and orientation. Unlike the disassembly process, which mostly required careful removal, reassembly demands verification at every stage. Each bolt, bracket, and connector must be installed in sequence, torque-checked, and tested for functionality before moving to the next step. The doubters argue that these complexities are why independent garages cannot perform hypercar repairs, but Mat's process demonstrates otherwise. By combining detailed observation, careful documentation, and precise engineering solutions, he has created a system that allows him to tackle one of the most technically challenging rebuilds ever attempted outside of a manufacturer facility. The decisions made this weekend, especially regarding critical components like the gearbox mounting bracket, will determine whether the rebuild progresses smoothly or encounters delays. Every choice balances speed, reliability, and risk, highlighting the intricate problem-solving required to achieve a successful result. Beyond the car itself, these engineering decisions carry broader implications for the automotive world. Successful independent rebuilds challenge the notion that hypercar owners are dependent on manufacturers for repairs and maintenance. They demonstrate that with skill, preparation, and access to modern engineering tools, independent garages can perform high-level work that was once considered impossible. The Chiron project, therefore, becomes a test case for independent repairability, with outcomes that may influence how manufacturers approach customer support and parts availability. In the future, one of the most compelling aspects of this Bugatti Chiron rebuild is the attention and scrutiny it has attracted from both fans and doubters alike. From the very beginning, critics have argued that while disassembling a hypercar like the Chiron may be within reach for a skilled builder, putting it back together without official manufacturer support would be virtually impossible. The doubters point to the Chiron's complex systems, intricate wiring, and sensitive electronics as evidence that only a factory-trained team could reassemble the car safely and correctly. Every bolt, bracket, and connection is seen as a potential point of failure in their eyes. Online forums and social media channels are filled with predictions of failure, with many observers claiming that Mat Armstrong will encounter insurmountable challenges due to the lack of factory knowledge, proper documentation, and access to original components. These criticisms, however, serve a dual purpose. While they create pressure and tension around a rebuild, they also highlight the significance of the project. By attempting what many consider impossible, Mat is not only challenging the doubters' assumptions, but also proving that methodical planning, skill, and ingenuity can overcome obstacles imposed by manufacturers. The scrutiny is relentless because this is more than just a car rebuild. It has become a test case for independent builders worldwide. Every decision Mat makes, whether to use a repaired bracket, a CNC machine replacement, or a source-use part, is examined and debated publicly. Some doubters focus on precision required for torque specifications, noting that even a small mistake can cause damage to aluminum components, cause leaks in coolant lines, or result in electrical faults. Others argue that the sequencing of assembly alone is too complicated for a single independent team to execute correctly. Despite this pressure, Mat's systematic approach, careful documentation, and engineering mindset provide a roadmap for overcoming these challenges. By labeling every wire, photographing every connection, and analyzing each component before installation, he creates a structured process that reduces risk. The doubters, who expect improvisation and guesswork, often overlook the meticulous planning that goes into every stage of the rebuild. Public attention adds another layer of complexity, as millions of viewers are watching each update, waiting to see whether the rebuild succeeds or fails. This audience amplifies both the stakes and the pressure. Community scrutiny can motivate greater precision, but it can also increase tension, as every small error becomes visible and open to judgment. The attention also demonstrates the broader cultural relevance of the project. Independent hypercar rebuilds are rare, and very few examples exist where someone outside a manufacturer service team attempts a full reassembly of a car as advanced as the Bugatti Chiron. The stakes are therefore not only mechanical but symbolic, representing the challenge to traditional manufacturer control, the empowerment of independent garages, and the assertion that owners should have the right to repair and maintain their vehicles without being forced to rely solely on factory services. This combination of technical difficulty, public scrutiny, and high expectations sets the stage for a dramatic and compelling narrative that goes far beyond a simple rebuild. The doubter's presence makes every bolt tightened, every bracket installed, and every connection verified a moment of tension and storytelling, ensuring that the outcome will be watched, analyzed, and remembered by enthusiasts and industry observers alike. The technical pressure surrounding the Bugatti Chiron rebuild is enormous. Unlike a standard car, the Chiron's components are designed and assembled to exacting tolerances, and every system interacts with multiple others in complex ways. The W16 engine, the gearbox, suspension subframes, electronic control modules, and intricate wiring harnesses all rely on precise alignment and proper installation. For instance, if a single connector is misaligned or plugged into the wrong module, it could trigger fault codes or even damage the car's control systems permanently. The titanium bolts securing the rear subframe to the front monocoque illustrate the extreme precision required. These bolts must be torqued to a specific value in an exact sequence. Too much torque risks warping mounting points, while too little leaves the components vulnerable to vibration and potential detachment. Each of the hundreds of connections Mat must manage carries a similar level of importance. Torque specifications, alignment, and sequencing are critical, and even experienced mechanics must approach the task carefully. Adding to the challenge is a lack of official service manuals, repair guides, or support from Bugatti. Mat has had to independently analyze every part, create his own assembly procedures, and develop custom solutions when necessary. This includes commissioning CNC machine replacement parts, testing repaired components for fit and function, and verifying that modifications will not compromise structural integrity or performance. Every engineering decision carries consequences, requiring careful evaluation of options, risks, and potential trade-offs. For example, choosing the CNC machine gearbox mounting bracket improves long-term reliability, but requires verification that it fits correctly with the W16 engine and transmission assembly. A repair bracket may be faster to install, but offers less certainty over durability. A used bracket, while factory spec, may not be immediately available and could delay the entire reassembly process. Each choice impacts the timeline, cost, and overall success of the rebuild. Beyond the mechanical and structural challenges, Mat must also consider system interactions that are less obvious, such as routing coolant lines correctly to prevent leaks, ensuring that wiring harnesses do not pinch or rub, and confirming that electronic modules communicate properly. Every step must be validated before moving forward. The technical pressure is amplified by the knowledge that failure would not only prevent the car from running, but could also reinforce the doubters' claims that independent rebuilds are impossible. Conversely, a successful reassembly under these conditions demonstrates that independent builders are capable of performing highly complex repairs and assembly tasks, even without manufacturer assistance. The precision and care required elevate the rebuild from a simple mechanical project to a full engineering exercise. Each decision, installation, and verification process contributes to the larger goal of proving that skill, methodical planning, and careful execution can overcome the barriers typically maintained by hypercar manufacturers. Alongside the technical and public pressures, financial and reputational stakes weigh heavily on the Bugatti Chiron rebuild. FXLXG, the company behind purchasing the crashed Chiron and funding the rebuild, has invested a significant amount of capital into the project. Every decision Mat makes, whether choosing the CNC machine bracket, repairing the original part, or sourcing a used component, directly impacts both the timeline and the budget. Delays or mistakes could result in wasted resources, additional costs, and extended work schedules. Beyond financial considerations, there is a significant reputational element at play. Mat Armstrong has established himself as one of the most skilled independent hypercar builders, and this project is arguably the most ambitious he has ever undertaken. Success will cement his reputation as a builder capable of handling the most challenging vehicles in the world. Conversely, failure, even a minor setback, could provide critics and doubters with ammunition to question his expertise. In addition to personal reputation, FXLXG's credibility as an investor and project supporter is also tied to the outcome. The stakes are further heightened by the visibility of the project. Millions of automotive enthusiasts, industry professionals, and casual viewers are following every update, making every decision highly visible and open to public scrutiny. Unlike standard rebuilds, which occur behind closed doors, this project is documented extensively with video, photos, and social media updates. Every error, delay, or successful milestone is broadcast to a global audience. The combination of financial risk, technical complexity, and reputational exposure creates a level of pressure rarely seen in automotive rebuilds. Each decision must consider cost, reliability, and long-term impact. This pressure drives a need for methodical planning and precise execution. It also amplifies a narrative tension for viewers, who understand that a single misstep could jeopardize not just a rebuild, but the perception of independent hypercar builders. The financial and reputational stakes, therefore, are inseparable from the technical challenges. Together, they create a multi-layered narrative where success requires not only engineering skill, but also strategic decision-making, risk management, and foresight. The project becomes more than a rebuild. It becomes a high-stakes test of competence, planning, and resilience under pressure. Documentation has been a cornerstone of Mat Armstrong's approach to the Chiron rebuild and illustrates why methodical preparation can overcome challenges that might seem impossible at first glance. During the disassembly phase, every step was meticulously recorded. Wiring harnesses were labeled, connectors photographed, and sequences of removal carefully noted. This process transforms a potentially chaotic rebuild into a controlled, repeatable engineering project. The doubters often assume that independent builders will have to rely on guesswork or improvisation, but Mat's documentation ensures that every part can be returned to its original location and orientation. Each photograph serves as a reference point. Each label provides clarity, and the recorded sequences allow the team to follow a logical, step-by-step plan. This level of detail reduces errors and mitigates risk during reassembly. Moreover, the documentation is crucial when evaluating alternative solutions for unavailable or repaired parts. For example, when considering which gearbox mounting bracket to install, the documentation allows Mat to verify how each option interfaces with the existing engine and transmission assembly. It ensures that modifications or improvements do not interfere with other systems or compromise safety. This systematic approach also underscores a broader message for the automotive industry. With careful planning and proper documentation, independent garages can perform highly complex repairs safely and effectively, even on vehicles that manufacturers claim require exclusive support. Beyond the mechanical advantage, documentation also serves as a narrative tool for the audience. Viewers can follow the process, understand challenges, and witness the logic behind each decision. It makes the rebuild not only an engineering exercise, but also an educational opportunity for enthusiasts who want to understand hypercar mechanics. The doubter's assumption that independent builders lack organization or precision is directly challenged by this meticulous record-keeping. By showing a methodical process that prioritizes accuracy and verification, Mat demonstrates that independent rebuilds are achievable, reproducible, and reliable. Documentation, therefore, is both a technical necessity and a storytelling device, providing transparency and reinforcing the credibility of the rebuild. The implications of this rebuild extend far beyond a single Bugatti Chiron. At its core, the project intersects with the right to repair movement, which advocates for vehicle owners and independent garages to have access to the information, tools, and parts needed to service their own vehicles. Manufacturers often maintain tight control over repairs, parts, and documentation, arguing that specialized knowledge and equipment are necessary to ensure safety and performance. Mat Armstrong's rebuild challenges this assumption by demonstrating that an independent team, armed with skill, preparation, and modern engineering tools, can successfully complete work that many believe was exclusive to factory service centers. If the Chiron can be reassembled and returned to full operational condition without manufacturer support, it provides a powerful case for consumer rights and independent repair capabilities. The rebuild also highlights a broader trend in the automotive industry, where manufacturers have attempted to monopolize parts and service, creating barriers for independent builders and owners. By succeeding in this project, Mat helps to establish evidence that these barriers are not absolute and that alternative methods can be both safe and effective. The outcome has potential legal and cultural ramifications. Demonstrating that complex hypercars can be independently serviced strengthens arguments for legislation supporting the right to repair. It empowers owners to maintain their vehicles, challenges restrictive manufacturer policies, and encourages innovation in aftermarket solutions. The project becomes more than a technical achievement. It becomes a statement about ownership, freedom, and the evolving relationship between consumers and manufacturers. For automotive enthusiasts, this makes the rebuild exciting on multiple levels. They are not only watching a technical challenge being overcome, but also witnessing a potential shift in industry norms that could affect hypercar ownership and independent garages worldwide. The stakes, therefore, are simultaneously personal, technical, and societal, combining into a story that resonates far beyond a garage in Miami. The weekend in Miami represents the culmination of months of planning, preparation, and anticipation for the Bugatti Chiron rebuild. Mat Armstrong and his team have arrived at CV Customs, where the Chiron has been waiting in two halves for reassembly. The atmosphere is charged with intensity because every step they take this weekend carries enormous consequences. The front monocoque sits on one side, while the rear subframe with the W16 engine rests on the other, and hundreds of connection systems and custom components must be rejoined flawlessly. What makes this process even more demanding is the presence of multiple pressures simultaneously. Community pressure comes from millions of viewers and enthusiasts who are tracking every update, expecting precision, speed, and a successful outcome. Doubter pressure adds tension as critics have already predicted failure, claiming that reassembly will expose limitations that disassembly did not. Technical pressure is significant because even a small mistake can cause serious mechanical or electronic issues, and every decision regarding bolts, brackets, and connections must follow exacting specifications. Financial pressure is another critical factor, as FXLXG has invested heavily in the project and expects a functioning vehicle, not just a pile of parts. Finally, reputational pressure weighs heavily on Mat himself. His credibility as a builder capable of taking on extreme projects is on the line, and this rebuild has become a public benchmark for his abilities. The combination of these pressures creates a high-stakes environment where methodical planning, careful decision-making, and precise execution are essential. Every bolt tightened, bracket installed, and component reconnected becomes part of a larger narrative, and each moment is watched and analyzed by viewers around the world. The team's approach is methodical. They refer to detailed documentation from the disassembly, verify fitment and alignment for custom and replacement components, and make decisions in real time about which solutions will ensure success. This careful planning is what separates a successful rebuild from a failed one, and the weekend in Miami has become a real-world test of skill, knowledge, and problem-solving under pressure. The outcome will determine not only whether the Chiron runs again, but also whether independent builders can challenge the assumptions of hypercar manufacturers and assert that ownership includes the ability to repair and maintain one's vehicle. A critical part of the rebuild revolves around the gearbox mounting bracket, the very component that initially caused the Chiron to be split in two. Mat Armstrong faces several options: a fully CNC machine replacement bracket, a repaired version of the original component, or a used factory-spec part. Each choice carries implications for reliability, installation time, and long-term performance. The CNC machine bracket, designed from 3D scans and with improvements over Bugatti's original cast design, offers a